The internet did not begin as a public tool. It began as a Cold War survival system. At 10:30 p.m. on October 29, 1969, a UCLA graduate student sat in front of an SDS Sigma 7 computer the size of a refrigerator and typed a single letter: L. The machine was linked by a long experimental connection to another computer roughly 350 miles away at Stanford. He added O. Then everything crashed. The plan had been to send login. History recorded LO instead. That half word wasn't staged for drama, and no one was thinking about symbolism in the moment. It was a routine test inside a Cold War research project run by the Advanced Research Projects Agency, better known as ARPA. The agency itself existed because of Sputnik. When the Soviet satellite went up in 1957, US officials worried they'd been caught off guard technologically. ARPA's job, bluntly put, was to make sure that never happened again. By the late 1960s, one practical concern kept coming up. Universities owned rare, expensive computers, and researchers kept mailing magnetic tapes back and forth just to share data. It was slow, awkward, and a little absurd if you think about it. The proposed fix sounded simple, though implementing it was anything but. Build a network. The early version, ARPANET, linked 4 sites: UCLA, Stanford Research Institute, UC Santa Barbara, and the University of Utah. Each location had a metal box called an interface message processor, which functioned something like a primitive router. Instead of sending data as one uninterrupted stream, the system broke it into small chunks called packets. Those packets could travel separately and reunite at the destination. At the time, that approach looked strange, maybe even risky. Telephone systems relied on circuit switching, meaning one dedicated line stayed open for the entire call. Packet switching ignored that model. Information behaved more like a stack of postcards than a sealed letter. If one route failed, the pieces could detour and still arrive. The design was decentralized on purpose, which likely appealed to military planners who worried about communications surviving an attack. Still, it would be misleading to say the engineers saw themselves primarily as defense strategists. Many of them were academics who simply wanted easier collaboration. They imagined researchers in different states running programs on one another's machines without boarding a plane or shipping equipment. The earliest widely used feature wasn't chat or media sharing, it was remote login. Practical, dull, and extremely useful. By 1971, the network had grown to about 15 nodes. Around then, Ray Tomlinson, an engineer experimenting with file transfer tools, adapted one program so it could send messages between machines. He needed a symbol to separate usernames from host computers and settled on @ mostly because nobody else was using it. Email spread quickly. In fact, it soon dominated network traffic, which suggests people were less interested in sharing processing power than in talking to each other. Expansion created a new headache. Different networks began appearing worldwide, each speaking its own technical dialect. Satellite systems, radio networks, university setups. None communicated smoothly. Linking them required a common language rather than a bigger single network. In 1973, Vint Cerf and Bob Kahn started working on a framework that might solve that. Their idea focused on rules instead of hardware. Transmission Control Protocol, an Internet protocol, eventually shortened to TCP/IP, described how packets should be labeled, transmitted, verified, and reassembled. Any network using those rules could, at least in theory, connect with any other that did the same. On January 1st, 1983, ARPANET officially switched over to TCP/IP. Some people call that the Internet's birthday. The moment itself passed quietly, which feels appropriate. Unlike the earlier LO incident, nothing visibly dramatic happened. Yet structurally, the shift mattered more. One experimental network turned into a framework other networks could join. For most of the 1980s, though, ordinary people had no idea this system existed. Its users were mostly researchers, defense contractors, and universities. There were no websites or streaming platforms. Navigating it meant typing commands into dark screens and memorizing numeric addresses that looked more like locker combinations than destinations. The next major leap didn't come from Silicon Valley. It came from CERN in Switzerland, where physicist Tim Berners-Lee was wrestling with a paperwork problem. Scientists from different countries were generating huge volumes of data, but their documents lived on incompatible systems. He proposed linking information through hypertext, allowing documents to reference one another directly. In 1989, he outlined what would become the World Wide Web. It's worth pausing here because people still mix these terms up. The internet and the web aren't the same thing. The internet is the underlying infrastructure, cables, routers, protocols. The web is a layer built on top, using standards like HTTP, HTML, and URLs to organize information. When the first browser appeared in 1991, navigating no longer required memorizing commands. You could point and click, which changed who could use the network. 2 years later, the Mosaic browser displayed images and text together on the same page. That sounds mundane now, but at the time it felt new and slightly magical. Commercial activity followed quickly. In 1995, the US government removed restrictions on business use of the backbone network, and private internet providers stepped in. Website counts jumped from around 10,000 in 1994 to more than 100,000 by 1996. Growth started looking less like a trend and more like a chain reaction. Looking back, each stage solved a different problem. Packet switching improved resilience. TCP/IP allowed different systems to communicate. The web made navigation accessible. None of those steps were designed with social media feeds or video calls in mind. Those developments arrived later, partly because the underlying architecture didn't block them. There's a popular story that the internet sprang from a single flash of genius. That version is tidy and cinematic. The real history is messier. It unfolded across universities, government offices, and research labs, shaped by trial, error, and occasional accidents. No single blueprint dictated what it would become, and no central switch controlled it. Even the word internet hints at that origin. It's short for internetworking, which describes a process rather than an object. The first message, LO, was incomplete, a fragment of login. Today, billions of devices from pocket-sized phones to warehouse-scale data centers communicate using the same packet principles tested that night. What started as 4 connected machines built for efficiency gradually turned into global infrastructure. Current estimates suggest hundreds of billions of emails move through it daily, alongside staggering volumes of data. Yet underneath the complexity, the core idea hasn't really changed. Break information into packets, send them along whatever path works, and let the network sort it out. That refrigerator-sized computer at UCLA is long gone. The student who typed those 2 letters probably wasn't imagining streaming films or cloud storage. Still, the system he helped test was built on a bold assumption. Information, it proposed, should travel freely between machines regardless of brand, location, or owner. It's hard to say whether anyone present that night grasped the scale of what they were nudging into existence. What seems clear now is that a Cold War precaution gradually evolved into something closer to a planetary nervous system, and it began, quietly, with a message that stopped halfway through a word.